All righty. Let's go ahead and get started. So a reminder, you've got a pair of vertical angles here, right? This one right here, right? You've got these two lines, they cross and they make vertical angles. Here's the north angle, here's the south angle. And so all we're going to do is we're going to set them equal and find our value of x, which is what they're telling us to do, right? So we've got 6x plus 2 equals 74. And we're going to solve for x. We're going to subtract 2. We get 6x equals 72. And we divide, and we get 12, right? 72 divided by 6. Let's see. So goes in once. Drop down the 2. Yeah, 12. Okay, good. So 6 times 12 is 72. Our answer here is 12. So what are we doing today? Today we are going to find the midpoint of a line segment and then find its length. There are two formulas we're going to go over. One is to find the midpoint. The other one is to find the distance from one point to another. And so as we're going through this, let's start with midpoints. We're going to start with the easiest thing possible. And as we're doing this, if we're given the two endpoints, right, we're given two endpoints. And we want to find what's in the middle. All we have to do is we have to take the x values and take the average of those, add them up and divide by 2. And then do the same thing with the y values. So basically, it's like two separate things. So for the x, we're going to do 8 plus 4 all over 2. That should be a 4. 8 plus 4 is 12. Divided by 2 is 6. So the x value here is 6, and then we're going to do the same thing with the y value. We're going to do negative 10 plus 3 divided by 2. Negative 10 plus 3 is negative 7. And as far as I'm concerned, when it comes to me, you can give me either answers. If you want to leave it as negative 7 over 2, you can. I don't mind. If you would prefer to divide it, simplify it, and give me negative 3.5, also fine. The only thing to be careful of, just like I keep saying, is if you're doing this on Math Excel, you got to ask yourself, what is Math Excel asking for? Are they asking for fractions or decimals? If they're asking for fractions, you got to give them negative 7 over 2. If they're asking for a decimal, you got to give them negative 3.5. But either way, your final answer should be written as an ordered pair, x comma y, because we're asking about what's the point in the middle of these two. And the middle of the x value is 6. The middle of the y value is negative 3.5. And this is my final answer here. So with this one, go ahead, give it a try. Same idea. All right, so first we're going to combine the x's. So negative 10 plus 2 is negative 8. Divided by 2 is negative 4. There's your x value. Now let's do our y value. Got negative 1 and negative 2. Negative 1 and negative 2 make negative 3. And again, the fraction works just fine. The decimal works just fine. It's up to you which one you prefer. Either way is good to me, as long as it's a complete answer. If you had to round, then don't do it that way, unless you are specifically told. But here's your x coordinate that's halfway in between. Here's your y coordinate that's halfway in between. So that's what we want. halfway in between the x's, halfway in between the y's. We're going to do one more. All right. So again, there's your x's, there's your y's. Make sure to identify which one is which. And now, what's halfway in between the x's? What's halfway in between 4 and 3? Right? What's halfway in between your y's? What's halfway in between 3 and 0? And again, any combination of these last ones here will do. If you want to stop here, the 7/2 and the 3/2, if you want to stop there, especially when you're handing things into me physically, that's fine. Or if you want the decimals, that's also fine. Just again, the thing to be careful of is on our program that we use for submitting work, they have specific ways to do it. It'll be in the directions. So make sure, okay? But so we're going to go through. So we're going to go through our final answer here. It should look like this. Again, our x comes first, our y comes second. All right? Questions? Okay. So here, the only thing that's different is just I've made a picture instead of just telling you what the points are. So there's a couple things that you can do. You can, if you like the way that we just did it, for one like this, you can literally just read off the points here. We've got the point 0, 3. And here we've got the point -2, -1. And you can now just do the problem as you see it. Here's your x 0 and -2. Right, and then your y is -1 plus 3/2. And then you get the answer of -1, 1. Or, you've got a picture, you might as well use it. Here's your horizontal. What's halfway in between this and this? What's halfway in between these two? And that's this, right? And then you look here, what's halfway in between this and this? Well, that's this, right? Just looking halfway in between, and you see that your point here is still the same thing that we're just talking about, the point -1, 1. Either way, you get the same answer, right? And so I'm not telling you what you have to do. There's multiple different ways to approach this, but I will tell you that any way you do it, you should still get the same answer, right? Whether you do it visually or whether you do it algebraically. You better get the same answer, whether you do it with your graph or you do it analytically. You should get the same result. I'm not going to tell you which way is best for you because only you know that. Try them both, see which one you like better. If you like one more than the other, please feel free to do that one as often as you can. If you like them both, it may behoove you to pick one just so that you have consistency. But if you're a fan of both, then you can just flip back and forth however you feel like. I don't care. That does not matter to me. As long as you get the answer right and you understand what you're doing, all is well. All right. Let's do another one. Okay. So with this one, just be careful. If you're doing it visually, this can be a little bit confusing. The x value is pretty simple. just in the middle right here. The y value can feel confusing because it's sort of halfway in between a number, right? But don't be afraid, it is exactly halfway. For something like this, maybe the algebra way feels more intuitive. Add the x values together, -2 plus 2. And then the y value maybe feels easier to work with. You get your answer that way. But either way, you do get the same answer. Whether you do it visually or whether you do it with the calculating stuff, that either way is going to get you the same answer. It's just a matter of, for the visual one and this one, maybe it feels a little bit less secure, just because it's not right on a lattice point here, right? It's not right on a one of these vertices where you can tell exactly what it is. But for something like this, it's gonna be exactly where you think it's supposed to be. Same thing. All right. Again, same thing as before. You're doing this visually. The y value might be a little bit tricky, but the x value should be pretty easy. Between 0 and -4, what's halfway in between? That's 2, right? Between the y values, here's 2, here's 1. This would be about halfway in between there, 1.5. And then we can double check to make sure that this is right by doing the algebra. So we've got -4 and 0. All divided by 2, and we add them up and we get -2, and that's what we got here. And we're going to do the same thing with our y value. 2 and 1 are our y values. We got 3/2, which is 1.5, which is pretty much what we were looking at right there. So our final answer, regardless of how we did it, had better still be 2 comma 1.5, or 2 comma -2 comma 3/2, right? Over 2. Okay. So now with this one, what we're gonna be seeing is, now I've been given one endpoint and one midpoint, and I've got to find the other endpoint. I've got to find the other endpoint. So, like, I'm looking for this. This is what I don't have. So I need to know what two numbers add up, and then you divide by 2, and then you get 9. Well, let me do that. Let me do that. I'm going to say, all right, well, here's my one endpoint. My other endpoint, I don't know. I'm going to put it here. But whatever that is, this makes 9, right? So let's solve for x. I'm going to multiply both sides by 2. At this, multiply both sides by 2 here. That cancels out this 2 down here. I got -5 plus x left over on the left. 9 times 2 is 18. And then I'm going to add 5 to both sides. Leave me with my value of x, which is 18 plus 5 is 23. So from -5, go up 14 and get 9. Go up 14 more. I better get 23, right? So let's do the same thing with our y values. My one endpoint is -7, right? The other endpoint, I don't know, but they add up They add up and then divide by 2, and then I better get the answer of 2, right? So let's solve for y. Once again, I multiply both sides by 2 to cancel out the fraction. And I end up with negative 7 plus y equals 4. And I add both sides 7 to cancel out that negative 7. I get y equals 13. And again, you look at this and you say, all right, well, I'm going from one endpoint to the middle. And that was up 9, right? When I go up 9 more, negative 7 to 2. 4. Oh, 7 plus 4 is not 13, is it? In fact, it's 11. There we go. Anyway, yeah, so I go up 9. Then I go up 9 more. 12 plus 9 better be 11. So here we see there's actually sort of two different ways to think about it. I would totally be cool with you. Thank you for correcting me, Jatavia. I appreciate it. I'm totally cool if you like if you see this part up here and you say, oh, look what's going on. I'm going from the endpoint to the midpoint. My x value is this much. My y value is this much. Well, it better be the same thing going to the other endpoint, right? Or if you want to do the algebra that I've done here, either way, you're going to get the same answer. I hope you should, if you're doing it right. So once again, it's like, well, two different ways to think about it. I can say, well, okay, here are my two endpoints, negative 5 and x. I don't know what that is yet. Well, let me figure it out. These two, when you take the average, you add them up and divide by 2, you get 9. So let's now solve this equation. Or you could say, all right, well, from negative 5 to 9, that's up 14. Well, let me go up 14 more. What do I get? I still get the same thing. Doing it up here, for y, better be the same process, right? My y value on one endpoint is negative 7. My y value on the other one, I don't know yet. So let me add those together, divide by 2, and I better get this number, which is 2. Well, let me solve this equation that I've made. Or you can say, well, I'm starting at negative 7, and I go all the way up to 2. That's up 9. Let me go up 9 more. Could be the same thing, right? Okay, so I want you to give this one a try. Same idea, different numbers. So as we're going through and doing this, once again, there's a bunch of different ways that you could approach this problem. I'm just going to talk about the two that I know. So again, one way, the algebraic way, is we're going to say, all right, well, let's look at the x value, and we're going to say, I can put an equal sign there. That's not what I mean. I don't mean equals. I'm just trying to say, hey, x. So my two endpoints are negative 6, and I don't know. So let me do that. Let me make that side of the equation. They should add up and divide by 2 to get the midpoint. And the midpoint is negative 10. So now I'm just going to solve for x and find the missing number. So I'm going to multiply both sides by 2. That'll cancel out the fraction. And then I'm going to get x by itself. I'll add 6 to both sides. And I better get negative 14. So that's my x value. Let's do the exact same thing for our y value. Again, my y values are 4 and I don't know. So let me do that out. 4 plus the thing I don't know over 2 had better be the midpoint y value of negative 6. And now let's solve for x again. Multiply both sides by 2 to clear out the fraction. Get rid of that. 4 plus x equals negative 12. And then I'm going to get rid of that 4. Negative 12 minus 4 more should be negative 16. Oops, I keep using x, but it should be y, shouldn't it? Y. Just want to keep our variables good and clear when you're doing this. Did I do this in the last one? Nope, I didn't. Just screwing up this time. That's okay. But the whole point is, here's my midpoint, or here's my other endpoint. So we look. So there's our x value, there's our y value. So let's look at it from the other perspective, right? So I'm starting at negative 6. Halfway to my destination is negative 10. That's down 4, right? From negative 6 to negative 10. So let me go down 4 more. Negative 10 down 4 had better be negative 14. And then we do the same thing for our y values. I was starting at 4, and I'm going to go down to negative 6. From 4 down to negative 6, that's down 10, right? Well, let me go down 10 more. Isn't that negative 16? Negative 6 down 10 should be negative 16, right? Okay, so this way works. Or you can just do this up here. I mean, either way, you're going to get the right answer. So, okay, let's look at this one. What do we got? Same idea. Okay, so let's go through. Again, we're looking for our missing endpoint. That's the thing we're trying to find over here. Whatever this is, whatever x is, whatever y is. So let's start with x. So I know the midpoint is 6. I know the one endpoint is 1. I need to find the other one. So we add up the endpoints and divide by 2. 1 plus the thing we don't know divided by 2 had better give us the thing in the middle, which is 6. So we're going to, again, solve this equation. So we're going to multiply by 2 to both sides. That'll cancel out the fraction. That's the reason we do it. And then we're going to subtract 1, get x by itself, and we get 11. And then we're going to go through and do the exact same thing for y. Our 1y value is negative 10. Our other y value, we don't know yet. But we want our answer to be negative 10 here. So we're going to once again solve. Clear out the fraction. We'll multiply by 2. We get negative 10 plus y equals negative 20. And then we are going to add 10 to both sides. And there we get our answer. And again, that's one way of doing it. We could also look at it this way. We could say, all right, well, I'm starting at 1. I'm traveling to 6. That means I went up 5. Well, let me go up 5 more. Well, if that's up 5. This is up 5. 6 plus 5 is 11. Well, that's what I got down there too, right? And then same thing. We're going to do the y value. Going from negative 10, I'm traveling, and I make it all the way to negative 10. Well, I didn't go anywhere. That's plus 0. So if I go 0 more, I'm still at negative 10, right? And, you know, that jives with what we got down here. And again, I'm not telling you you have to do it one way versus the other. I just showed you 2 perfectly good ways to do it. You pick the one you like best. That's fine. All right, what are we doing now? Now we're going to find the distance. So there's a bunch of ways to do this. In your textbook, they do give you a formula. This is one of the first actual formulas that you're actually going to get, the distance formula. And I'm going to put this here, and it's kind of gross looking, kind of complicated looking, and I apologize in advance. That's just the formula that they give you. It's basically the difference between the x values squared plus the difference between the y values squared. I'm going to write it like this first, square rooted. So all I'm saying is, like, the distance from one to the other for the x, right? What's that difference? What's for the y value? What's that difference? Square that number and then square root it. So in your book, they don't give it to you like this. In your book, they make it look like this. So in your book, they give you this one, this bottom one here. Really, what's going on is just, okay, well, what's the x distance? This little delta symbol means change, right? What's the change in x? Where are we going, right? What's the change in y? Where are we going? But either way, it's going to be the same thing. If you want to, so me personally, when I do this, I prefer to use this top one because I can sort of jump straight to the chase. But if you want to go through this bottom one is totally cool. If what you want to do is you want to say, all right, well, here's my x1, here's my y1, here's my x2, here's my y2, and just plug them in and then do that out. But like here, it's going to be a lot easier to just go through. Well, I'm going from -5 to -8, right? So I do this. Notice how I always keep my square root. -5 to -8, that's -3. Let's do the y's now. 1 to 4, that's +3. So now I've got -3 squared. Anything squared is positive, so -3 squared is just 3 squared, which is 9. 3 squared is also 9, right? 3 times 3. I do this out and I get radical 18. Now, that right there is not done because we can simplify that radical. So if we look here, radical 18, we're going to break it down. Now, there's a bunch of ways to do this. I'm going to show you one way. If you don't like that way, I can always do it in many different ways. There's thousands of ways to talk about how this gets broken down. But I'm going to make a factor tree, put together all the prime factors. 2 is a prime number, right? I'm going to always circle my primes just so I know. I'm just breaking this down into its pieces. 18 is 2 times 3 times 3. What I have here is like that. Now, if it's a pair, it gets to come out. If it's not a pair, it has to stay in. So that pair of 3s comes out. And what's left over is the 2 that doesn't have a friend to hang out with and go chill outside. So this is one way of taking this square root and breaking it down. I'm not telling you it's the only way. If this way feels really alien to you, I can show you another way. Let me take this and sort of move it to the side a little bit. No, I don't want you coming with. Just you. Okay. All right, well, I guess you are coming with. That's fine. So the other way that I've seen pretty commonly is to do it like this. is to look for the biggest perfect square that goes into 18. And I always like to make a list. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. We are now bigger than this number, so I can stop. 25 does not divide evenly into 18, nor does 16, right? 18 divided by 16 ain't no whole number, right? But 18 divided by 9, that's 2, right? Well, the perfect square here, I can take a perfect square. I can square root that, and I can get 3. And then this 2 stays inside the radical. Either way, it's the same amount of effort, same amount of work, all that. You're going to get the same answer either way. It's just a matter of which of these ways to explain it do you prefer. I personally, when I'm having trouble and I just don't see it immediately, do this way just because it always works. But I will tell you, practicing this method, or either method, really, practicing either method, you're going to start seeing patterns, and it's going to become a lot easier, but you got to practice. You got to practice. All right, so either way, your final answer, your full points final answer is going to be 3 radical 2. Radical 18 is not going to get you full points, so just be aware of that. All right, let's look at another one. All right, so once again, let's find that distance from -8 to 0. This is my change in x. Well, what's my change in x? From 8 to 0, that's a distance of 8. What's my change in y? From -6 to 0, that's a distance of 6. And so 8 squared is 64. 6 squared is 36. We add that up, we get 100. And now, oh, wait, look, 100, that's a perfect square. The square root of 100 is just 10, isn't it? Not radical 10, just the number 10, right? And that's your answer. When it's a perfect square under here, don't overthink it. Don't try and do extra. Recognize your perfect squares, and then take the square root and get your final answer. All right, one more. Okay, so with this one, again, we're going to change of x squared plus change in y squared. And, well, from -2 to 0, that's a distance of 2. From 3 to -2, that's a distance of -5. And again, whenever you have a negative number underneath a square like this, -5 squared, that negative goes away, period. I don't care what your calculator says. If you typed it into your calculator and came out with another negative number, you have typed it into your calculator wrong because you don't know how to use it yet. 2 squared is 4. -5 squared is 25. Positive 25. Once you've done your squares, if you still see a negative underneath this square root, you're wrong. Period. So if you've got a negative under here, at this point, you are officially and irrevocably wrong. 5 ever. I'm sorry. We left with 29. Now, I want to see if this can break down. You know, just like the last couple. Well, 29. What two numbers multiply to get 29? Oh, just 1 and 29. So I don't have any pairs, so I can't break this down. This is officially as far as you can go. 29 is a prime number. There's no way for you to break it down any further. So just be aware. Prime numbers, awesome. Less work for you. You don't have to do anything. Perfect squares, awesome. Take the square root, you're done. Where it becomes confusing is when it's neither a prime number nor a perfect square. You have to double check. Are there any pairs of factors that come out? Well, here there's 2 3s, right? There's a perfect square of 9 that is a factor of 18, so that can be brought out. That's what we're talking about here. Lastly, the only other thing I have for you is just the exact same thing, but in picture form. So, as with the other stuff, there's multiple ways to do this. My favorite way to do this is to turn this into a Pythagorean theorem problem. Right, because that's where the distance formula comes from. It's just a, it's just an application of the Pythagorean theorem. All I have to do is say, all right, well, this side is 3, right? This side 1, 2, 3, 4, 5, 6, 7, 8, and then a squared plus b squared equals c squared. And then square root. And 73 is another one. It's actually prime. You can't do anything with it. So you're just going to leave it there. Now, take a look at how this one looks compared to just using the distance formula like I showed you in the last 3 problems. I want you to see how it's the same. See if I can move all these. Oh, I can move that. Can I move these? Okay. Let me move you all over here. Okay, so take a look and see how it's the same. Well, what's this point? This point is -1, 5. What's this one? This is -4, -3. Right? Well, let me do that just the way I did it previously. Change in x squared plus change in y squared equals our distance. Well, what's our change in x? It goes from -1 to -4, so that's a distance of and then this one goes from -3 all the way up to 5. That's a distance of, and so -3 squared is 9. 8 squared is 64. Add them all up, you get 73. Hey, isn't that the same answer here as here? It really basically boils down to in what order are you doing things? But this is the Pythagorean theorem, right? And just solving for the value. And then this is the distance formula. Notice how it's basically the exact same thing, except this one starts out with the radical over top, and then you've got to do all this shenanigans on the inside of the radical and come out with your answer. This one, you're solving, and then finally you take the radical at the end. It really boils down to how do you want to do it? You're going to get the same answer either way. You'd better, right? So let's do another one. Give this one a try. You can use any method you like, as long as you get the same thing I do. Okay, so let's talk about it. Again, there's 2 different ways to do it. If you like the way that we did it in those previous problems, that's cool. You can do it any way you like, as long as you get the same answer that I do. So, you want your square root here. You've got -4 to 4. That is a delta x squared, delta y squared. That is a distance here of 8. You're going to do the same thing with your y's. From 5 to -3, that's -8. So 8 squared is 64. -8 squared is also 64. 4. All right, and then you add them up and you get 128. And then it becomes a question of, all right, well, I want to find the perfect square that goes in here if possible. Let's go through and check. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36. I'm just keep on going. 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, and then 12 squared is 144. That's too big, so I know that that's out. We can go through and we can divide, right? 121 doesn't go into 128 evenly. 100, no. 81, no. 64 does, though, right? 128 divided by 64, it better be 2. So this is really 64 times 2. Well, what's the square root of 64? 8. You know, or if you prefer to do it the other way, you can just break it down to a whole bunch of 2s. Just figuring out what the numbers make you a factor tree. And we count, there's 1, 2, 3, 4, 5, 6, 7. How many pairs do we have? There's 1, there's 2, there's 3. So we got 3 pairs of 2 on the outside and 1 leftover 2 on the inside. Well, this is 8, right? Either way you do it, you're going to get the same answer. You better. But other than that, that's about all there is. I think I might have one more. Yeah, it's the same thing. So let's just go over it together. Let's use the Pythagorean method this time. This has a length of 3. This has a length of 4. So our delta x is 3. Our delta y is 4. 3 squared is 9. 4 squared is 16. Don't forget the square root over the top. Add them together, you get 25. And what's the square root of 25? Isn't that just 5? Ta-da! And that's the answer.